Hi all, my name is Kiran here. Okay, seeing this, let's get into our agenda today. So we will try to talk about what are neural networks, the motivation behind neural networks, then what exactly is neural networks. We'll start with why, motivation, and what exactly. Then we will talk about single layer perceptron and multi-layer perceptron. Then we will see an implementation of an use case and also talk about various industry verticals where neural networks is being used. So why a neural network, right? So we will begin with this reason. So all these days, predominantly when we have these computers where agents or the systems which can do a problem or which can solve a problem for which it is programmed for. So when we say that, possibly before a computer can solve this program, it has to be explicitly made sure that the commands are well articulated and the machine can run those commands within its boundaries, which also means that a person who has to write the program has to first solve the problem or know the problem and have a solution for it. Then he can make the computer work for it. But that is also a gap in sense, when there are new decisions to be made or things have to be made the way the human being does make his actions, computers fail. Right, today the computers cannot make their own decisions explicitly. The decisions whatever are made are with the programming conditions, which means the computer follows a set of instructions in order to solve a problem. This restriction of solving the problem only with regard to the instructions, and if that boundary can be eliminated and if we can bring in the learning quotient into computer, if we can bring in the learning quotient within computer and make computers learn on their own and take decisions, then this part of doing that is your machine learning. And part of machine learning, when the data is deep and the decision taking quantum is very high, we get into the section of neural networks or deep learning. So saying this, we'll see how it changed the system once the neural networks were introduced. Neural networks, computers can do exactly what the things or how the things the people do. In a neural network, you have an input layer, you have the hidden layers, and you have output layer. They cannot be programmed for specific conditions, but they will be made to learn for various permutation combinations. And on this learning, the neural network becomes intelligent enough to make runtime decisions to solve the problem. So this quotient of making use of a connected network of neurons to take decisions from right from its input layer till its output layer becomes a neural network, right? So that is how the neural network works. Now, saying this, the motivation behind neural network is the human brain itself. Though we all know man himself has not been able to understand the working of the brain completely, with whatever the limited understanding the human being has about his own brain, we are trying to mimic a similar situation, and we are trying to build a neuron which is like your we are trying to build or replicate the way a neuron works. So a neuron at the outset has three elements: the dendrite, cell body, and axon. Dendrite is an input layer which the cell or the dendrite receives the information from its other axon. Once the dendrite receives the signal from other neurons, it passes the information to the cell body, which does all the computation. The computation can be anything. The computation can be anything which is like sum of all inputs or sum of anything, and then your information is passed from cell body to axon. Once the information is passed into the axon, the information goes into your next neuron. So this is what we try to see and make a neural network work in a similar fashion. So if you have to see this, what are artificial neural networks, right? Are predominantly called as ANN. ANN is a computing system inspired by biological neurons that constitute animal brains, right? Basically, if you see this diagram, we have few images of dogs. And if you have to train the machine with these dogs and try to show an image which is not in particular to any of the dog which we see here, probably the machine will not be able to recognize this dog in this family picture. Right, so predominantly here the images on which the computer was trained versus the image which is shown, when it is shown to a human being, he is able to identify the characteristics which are more or less similar, and then he is able to identify within the picture. And for that matter, if you have to see identification of a puppy or a kitten, right, both are newborn, puppy or a kitten, human himself will take some time before he can identify which is kitten, which is puppy, as against a dog or a cat. A full grown cat or a dog, it becomes immensely easy for a human being to identify. But for a puppy or a kitten which are just born, we have to concentrate for a minute or 30 seconds before we can identify, seeing some varied features. It can be the mustache, it can be the nose, it can be the eyes, some distinctive features which we will have to do some deep viewing, after which we will be able to say which is your cat, which is your kitten versus which is your puppy. So in a similar fashion, without neural network, the computer will not be able to identify a dog within this picture. With neural network, the computer will be able to identify, or the algorithm will be able to identify some matching parameters with the trained dogs, what it already has, and be able to identify this as a dog within the picture, which means doing such distinctive activity within a cluster of objects is possible with your artificial neural networks. So saying this, how exactly it works? We did try to say why artificial neural networks, and we did try to see how, what was the motivation, but how will it all work, right? To get to the nuts and bolts of the mechanism which makes it work, we will see this. So if you see, there is an artificial neuron which is more or less similar to the biological neuron. So there are your input parameters, which are your X and Y. So when you have your X and Y as your input parameters, you also have your weights. The W1, W2, W3 are your weights. So we will talk about what are weights, how they influence your decision when we go to the next step. Once we have the input and we have the weights, we do the processing of that weights, which is your summation. So it can be the calculation of your input parameter and your weights, which gives a value to your output or a neuron to see if it has to fire or if it has to do nothing, right? Once Y gets a value for a threshold point, then the neuron fires. So this way of trying to mimic the way human brain works is artificial neuron. Here, as the machines understand only numbers, we are trying to convert all these decisions into a format which the machines can understand. We have various approaches. We will go through them, all of them. So till here, we were able to get few things on what is artificial intelligence, what is the neuron, how neuron is connected to a biological neuron, and how did we do that particular thing. So once we have this, which we call as perceptron, right? the perceptron has two models. One, the training mode and the using mode. What happens in the training mode? In the training mode, the neuron can be trained to fire or not fire for a particular input. So if you have to see ourselves, human beings also sometimes take decisions, or rather many times take decisions on few parameters. That instance of activated information is called your firing. And so sometimes we are just thinking and we suddenly remember something for us to carry an activity, which means at that particular point of time some decision did get weight on some activity for which a particular neuron in the brain got fired. So this activity, when we have to do that over neurons, artificially built neurons, it is called as the training mode. And once we have that trained network, we can get into the using mode. When a thought pattern is detected as the input, it is associated output becomes the current output. So in this case, whatever we are doing, basically it gets to and stage where your training and using modes both are well done, right? So here the neuron, what has been provided with the input gets to feed in all the information, consume and ready with a model, and that particular thing will be ready to be used. So that is the using mode. Then in the artificial neuron, you have various activation functions. When I say activation functions, this is when the neurons get fired. So there are many more activation functions. Here we are trying to see few of them. A step function, when the threshold value comes at this point of time, the activation or the neuron gets fired. We have a sigmoid or an S function. We have a sign function. When there are negative and positive values, sign function works. When it is between 0 and 1, many times a sigmoid function works. All these things predominantly helps a neuron to get fired or get activated for a certain stimulus. Now let's try to see, we know we have been talking about various things. Let's try to talk and understand with an analogy. Okay, so this is an interesting analogy. Let's see, from a beer party. We will think that there is a beer party happening near our house, and there are three influencing factors which can help us to decide whether to go to that beer party or a beer festival. The influencing factors are: what is the weather, or how is the weather like? Then, is your spouse joining you, right? And the third one is any public transport available. So when you say is the weather is one of the input parameters, is spouse joining you or going with you is the second input parameter, and the third input parameter is your public transport. When you say public transport, the public transport can be in any shape and form. So basically we are trying to see this analogy to see how we calculate the inputs, how we calculate the weights. Saying this, let's try to see the three input parameters. How is your weather? Is your spouse joining you? And public transport, which is your x1, x2 and x3. So is the weather good? You want to go, which is your value 1. If the weather is bad, you don't have you are not willing to go, which is 0. If your spouse is joining, right, then you have the value as 1. If your spouse is not joining, you don't want to go, you want to stay back at home, so that is your 0. Then if public transport is available, then you want to go, and if the public transport is not available, you don't want to go, you just want to relax. These are your inputs, and the outputs of that will influence you to decide whether you want to go to the beer festival or you want to stay back at home. Now once you have this particular thing, the whole value of 0 and 1 will influence you whether you are going or not going. Saying this, let's try to see how you will prioritize the factor. When we see these points, we don't have all the points with the same weightage, right? Some factors have some higher level of importance, some factors have lesser level of importance. That is what we call as weights when we come to your neural networks. As human, we may decide whether is very important versus spouse joining or public transport, or we can say that spouse joining has a higher weight versus weather and public transport. So this factor of prioritizing things or getting influenced for any other input is your weights. So let's try to see when we assign weights, how does this work? Now, if we did see W1, W2, W3 are your inputs, right? Sorry, W1, W2, W3 are your weights for your associated inputs. X1 was with regard to the weather. If the weather was good, you wanted to go. If the weather was bad, you did not want to go. The W2 is the weight associated with your input, that is your spouse joining you or not joining you. W3, which is the input with regard to public transport. Now, if you have to see, if you have a threshold value of 5, right? Let's see how does our weights and input factor. Now, if I see your W1 is equal to, we say that the weather is good and our weight is 6, so 1 into 6, which is 6. Then we will say W2 is equal to 2, while we say that the spouse is not accompanying, therefore this becomes 0 and your 2 is equal to 0. And you have the third thing, which is your public transport. Assume there is no public transport, which is 0. 0 into 2 is 2. 0 into 2 is 0, right? So it becomes 6 plus 0 plus 0, which is for your first input, the value was 6, while your second and third input, the value became 0. The value 6 is greater than your threshold value 5. The threshold value here for you to go for that beer party was 5, but the value what you are receiving is 6. So for this weight, you are probably planning to go. Now, if we change the weights and or if we change the threshold and we change the input, let's see how does it perform. Now, we will say that the threshold value is 3, weather is bad. W1 will become 0. So the weather is bad, 0 into 6 is 0. Then your spouse is accompanying you. So 1 into 2 is 2. And let's assume there is a public transport also. So 1 into 2, which is 2. Therefore, 2 plus 2 is equal to 4. And the value of 4 is greater than threshold. So you will still go to the beer party. Assume in this case your spouse was not joining, this value will become 0. So 0 into 6 is 0, 0 into 2 is 0. Then 1 into 2 being public transport available, 1 into 2 is 2, while 2 is not greater than 3, the neuron will not get fired, which means you will not go to the beer party, right? So this basically when it fires when the value becomes higher than your threshold value. This way of taking the inputs, assigning the weights and trying to see the output, get the model trained for all permutation combinations, and then getting your neurons work the way it has to be based on its learning is something which we are trying to see here. So this was basically an analogy for us to see how we assign weights and how do we calculate the fire or no fire from the neuron. Then coming into the next section. So multi-layer perceptrons, right? So we see this in the real life scenario, we will not have one input or nor one decision to make, right? As human, we have more than 5, we have 5 senses: the eyes, nose, ears, touch, smell, all these things, and all these sensory items give us so many inputs, and there is a combination of all these inputs before we can take some decisions. So for example, the way you taste your food when you're hungry versus the way you taste your food when you're full is very different. All right, so all these inputs will help you to decide to make a decision. Similarly, when we say that our brain has to make such decisions, we have millions of neurons. To make such decisions on a machine, we need a good amount of neurons to make the decisions from the inputs what we get. So if you see this, the first layer is your input layer, which will take the inputs from various parameters, and then it will pass it through your second layer, which is your hidden layer. There can be multiple hidden layers based on the amount of inputs and the weights what has been put on that particular neurons. So once the data gets input here, consumes, calculates, and the output, it gets into your hidden layer 2. And once the number of hidden layers are completed, then it gets into your output layer. So it is just predominantly this way of connected ways where we are doing is a multi-layer perceptron. So if you have to read this, basically neural network is really just a composition of perceptrons concentrated in different ways and operating on different activation functions. Each neuron might have a different threshold point, and for different threshold points, the neurons can get activated. So building such network of neurons for activation to influence a decision is your multi-layer perceptron. So let's see the way an image is being recognized. So imagine, before even seeing this particular thing, imagine you are seeing an image which is a cluster of faces. If you have to sit back and remember yourself last time when you have seen an image with cluster of faces, it can be your college group photo, right? The moment you see the photo, you take a minute or two before you can recognize your close friend, or in many cases it might take few seconds for you to identify where you are in that particular group photo, which means the brain will start searching for some patterns within that particular photo, because this is a photo of cluster of many faces. So first it has to recognize the pattern of local contrast, which can tell these are all the places where you get to see the face. Once you get to see that particular thing, you get to go to your second layer of trying to identify the face features. So it might be your close friend, you might have some other friends all standing together where you are trying to identify some features, and you are trying to detect, oh, the person with the small hair or the person with the bright eyes are your friends. So that is what you get to identify as a second step, which is your face layer, and then you go and identify and see distinctively to identify your face. The same action we get to do here when we have our neural network identifying a cluster of images. So if you see this, this is an image with many faces. It becomes your input to your input layer, which identifies your patterns of local contrast. Once that is done, it gets fired to identify your next thing, which is your face features. Once the face features are identified, you try to identify the actual face, which is your hidden layer 2, and then you get into your output layer, which is the actual face which you get to see. So this activity of doing things through multiple layers, streamlining, downstreaming the whole input and making it as a decision to flow it into next level is your artificial neural network. So let's see how we can train the neural network. We did see this, right? Basically, we said it will start with one layer, get into all the layers and get going. Let's see this analogy, or let's see the way the neural network training happens. Because for any neural network, there are two activities which has to happen. One is the training and testing. In the training, we are predominantly making the neural network learn some specific activity, and in testing, we are passing something and making it to test the things. So if you see this, the input is 0, 1, and 2, and the desired output is 0. This should be 2, and this is 4. Basically, we know we are doubling, right? So this is a desired output. Once we have this desired output, it is doubling. As a human being, we can understand, but how can we make the machine understand that, right? So let's see, with a weight, we add a weight. So our input is 0, 1, and 2. Desired output is 0, 2, and 4. And we put a model of 3. 0 into 3 is 0. 1 into 3 is 3. 2 into 3 is 6, which is our modeled output. This is our desired, this is our modeled output. Now, once we have this modeled output, we calculate the absolute error. So what is an absolute error? The difference between the model and the input. So we have 0, this is 1, and this is 2. Now, once we have the absolute error, then we do the square root of that particular thing. So it becomes 0, 1, and 4. Then once we have this, we will try to change the weight, and we will increase the weight from 3 to 4. We get this output. It becomes 0, 4, and 8. Once we have this thing, we will again calculate the squared error, which is our 0, 4, and 16, which means as we increase the weight, the error is increasing. So probably we should not increase the weight, we should decrease the weight to reduce the error. So this is called as backward propagation. So in this case, based on when the errors are increasing, the system identifies that and it goes backwards to reduce your errors to a point where the error is the least. So if you keep increasing, if the errors are increasing, then it has to start reducing. If it is reducing the weights and the errors is increasing, then probably it has to start increasing. So this way, the weight versus squared error is calculated, and your absolute weight or a correct weight is calculated to see how your neuron can be fired. So this particular thing of making your neuron change the weights and get going to determine an absolute or a correct weight for you to fire your neuron is training the neuron. So let's take a use case, right? We have been talking about the theory behind how neural networks works and what happens. Let's try to see in action. Now, let's see, we have a use case where we have to determine a currency, if it is a real or a fake currency, right? This is an obvious thing, and as human, when we have to decide whether a currency is a original currency or a fake currency, we have our own parameters. We might be seeing the texture of the note, or we check for a few parameters within the currency note. These parameters will help people identify whether a note is a original or a fake note. Now, if you happen to see, we have a data which has this 4 parameters, where we have the variance of the wavelet transformed image. So this is the data which is collected from a set of collection from the original and the fake currency notes. So we have our variance of the wavelet transferred image, then the skewness of wavelet transferred, kurtosis, and entropy. And the last label which we are seeing here is basically giving us zeros and ones. So when we say it is 0, it is a fake note. When it is 1, it is a real note. So basically this was the data extracted from images of genuine and forged notes. The images were of 400 into 400 pixels, and due to the object length and the distance, we were able to get this particular wavelet transform readings. So once we have this particular thing, let's try to see how the use case can be implemented. So when we have to see this, we basically start with reading the data set. Then we define the features and labels, whatever is the labeled information we have from this particular thing. Then we divide the data set into two parts, which is your training data set and testing data set. And then we use TensorFlow for holding features and labels. So TensorFlow is a library in Python by Google for doing deep learning. And then once we have the TensorFlow defined, we will implement the model, and then we will train the model to reduce the mean squared error. So once we train, we reduce the mean squared error. The actual output minus the desired output is your mean squared error. And once we have the minimum mean square error, then we will make the prediction on the test data. So this is an approach in which we can train a model to detect our original and fake nodes. So let's saying this, let's see the code which we have developed. So let me come to the actual code. So if you see this, this is the actual code to identify the fake nodes. So the first and foremost thing is to import all the required libraries. The matplotlib is for your visualization. Then we have TensorFlow. We have the NumPy for your calculations of arrays. Then we have pandas to read the data from our Excel or CSV file. Then we have the scikit-learn for pre-processing and model selection. Then we get into the section where we are reading the data set, and if we want to see our data, we print that data, the X and Y, and then we go into the encoder function where we use various encoding definitions and get our input. Once we have that encoding, we read the data set and shuffle the data set to start the training. Once we have this data set in the trained mode, we can also see the trained data set. Once we have this, basically we are importing the parameters and the values to work with tensors. Tensors are your neurons, right? Like your neurons in TensorFlow, you call it as tensors. The learning rate is the weight at what rate you do your learning. And epochs is the number of iterations. Once we have put around 100 iterations for us to learn or train the system. Now, once we have this, we have to go and define the number of hidden layers. Here I'm taking 10 neurons and 4 hidden layers. So we have hidden layer 1, 2, 3, and 4. Then we define our various parameters for that particular thing, and we define our model for hidden layer, which is the ReLU activated approach. Then for hidden layer with the sigmoid approach, the hidden layers, and then we again have our ReLU for your output, and we go with the weight definitions. Once we have the weight definitions, we get into all the variables and do the calculation. Now we have to define our cost function for our optimization, and we pass this into each iteration where we get our learning rate and accuracy defined. Once we have that, we save that particular path and we get our output, and we are also plotting the accuracy and label. Once we have all of this, we print the final accuracy and we print the final mean squared error. Let me copy this code and run this particular code. So usually such models take some time. Let's try to run. I have also run this and kept it, so we can see that as well. So let me put here. And once I start my thing, predominantly, if you see this, the number of iterations or epochs are increasing, and with each increased rate, my accuracy, the training accuracy is increasing. It started with 55%. It is with the 12th iteration, it is already at 86%. So if you keep seeing down, around 60th iteration is what we are at 99%, and probably in another 10 or 12 iterations we might have more learning. So at 88th iteration, it actually hit 100% of learning. and let's try to see this. Okay, so if you see this, we also see the graph, right? So it started off here at the 12th iteration, it hit around 85 or 87%, and probably at around 80th iteration, it almost hit, or it hit 100% of learning. So once that learning, we see the test accuracy of 1 and the mean squared error of less than 2%. So this is how you basically created a model which consumed the data and it is able to get itself trained to an accuracy of almost 100% because this model is trained with multiple data once or twice before this session. So it hit 100%. But if you see with the new data, probably the accuracy might stop at around 95, sorry, 98 or 99% and get your accuracy. So with this, we were able to train the model. Now, when we feed this data with the new data set, the accuracy of prediction will be 100%. So you will be able to see whether a note is original or fake. So this was an use case to detect your fake currency. Coming to the application. So we see various applications for neural networks, especially in diagnosing and the cardiovascular system. Image recognition being the biggest strength for neural networks. It is being explicitly used in various image-driven diagnosing like your MRI or CT scans and all this, where you can have your idealistic images and then you have to compare it with patient's images, and you also use it in electronic noses. So what are electronic noses? Is predominantly a way or telemedicine, right? What we have telemedicine is prescription via a distance communication. So for this, you use your neural networks to understand the input criteria and come with a prescription. And if you have to see the neural networks in your business, it is extensively used in your marketing. So various images, especially if you have to see, there is also this website called as the person does not exist. So if you go to this website, this person does not exist. So this is a website which is created using one of the neural network called as GAN, where every time we get to this website, the image is created with a fragmented images which are available across the internet, and a new image is created, and as the name suggests, this person does not exist, and each time you refresh you get a new image. So if you get time, you can go to this website. They give the details on how they are using the GAN model to create such images. So if I just try to refresh and show you, you get a different picture, and theoretically speaking, this person who is created does not exist in the world, right? So then for your credit evaluation in banking and insurance, or rather banking and credit departments, so basically you have large parameters of data to be analyzed and decisions have to be taken on that large collected data. So of late in many of the countries, your small requirements of your personal loans or credit card approvals are happening instantaneously because the credit evaluation system is able to handle that large data sets and make decisions which usually were operational in nature. Now with this proven models, you are able to get instant decisions and get your loans approved instantly. So these were few use cases of your neural network. Okay, so if you have to see in nutshell, what did we see today? So basically we try to understand why neural networks, where the computers basically have a challenge today and how we can address this challenge using your neural networks. And then we try to go into what is neural network, where we said that how a neural network will be able to identify based on its training a new set of image which has a dog. And then we did talk about the way a artificial neural network works, the perceptron, and spoke about the multi-layer perceptron, where it will have input layer, multiple hidden layers, and then the output layer. And then we went into training of this multi-layer perceptron, went into the use case to implement this and get your output. So this was an attempt for us to understand neural networks, to see the three things, right? Basically make the computer understand how the calculations go in and how the final result come in. This was the thing what I had for this session. Anything, you can feel free to connect us on the website. Okay, thanks guys, thanks for your time. Bye.